Good morning, everyone, and welcome to the first in our Winter Storm Stories series. We will be talking about snowstorms. My name is Andrea Berg, and I am your host today. I am joined by Brad Nelson, who is a meteorologist and solution engineer and really does everything at DTN. Um, and he will go through a case study about a winter storm that happened last December, and then go through how some of our solutions for our storm risk products can help you manage and hopefully mitigate some of the issues that snowstorms can present to utilities. So with that, I'm going to turn the presentation and the webcast over to Brad.
Awesome. Thanks, Andrea. Thanks everyone for being here. And this is the first of our Winter Storm Stories series. We're going to cover with snow, ice, and extreme temperatures, a couple of case studies, some extreme events, and then talk through, how utilities and other industries can handle and manage and help mitigate their risks and deal with these types of big weather events as we lead up to, during, and then after the storm during restoration. So let's talk about an event that occurred on December 13th through the 16th of 2022. And that is the blue blizzard, that occurred in northern Minnesota, northwest Wisconsin. Pretty extreme event that occurred. It was a very heavy wet snow event with 1 to 2 feet of accumulation over 4 days and maximum amounts up to 30 inches that occurred primarily along the Lake Superior lakeshore in far northeast Minnesota along the Iron Range. This was a pretty extreme event. We don't, in this area, compared to some more of the southern states, even the Ohio Valley, Mid-Atlantic, you don't get a lot of extreme wet snow events due to the cold air and the drier air that's typically in place across this area of the country, and into southern Canada as well. But this storm certainly packed a punch. Most of the accumulation occurred over a couple-day period of the 13th and 14th. But it was nicknamed the Blue Blizzard because, interestingly enough, it had a blue tint of the snow that was just mainly due to the high water content, the high moisture that was in place. So it's very unique how, this very heavy wet snow event and a blue look to, almost aqua blue look to the snow. It began as a wintry mix, sleet, freezing rain, snow, and then quickly turned to snow on the 13th. And it snowed very heavy through the morning of the 14th. This initial wave brought 6 to 12 inches of snow initially, and then it started up again on the evening of the 14th. And I'll show you some radar captures right after this of the individual waves. But it lasted the evening of the 14th, then into the 15th. It brought another whopping 8 to 20 inches of snow. So pretty crazy snowfall amounts over a couple-day period. And then we had lighter snow with another 2 to 4 inches or so that occurred from the 16th through the 17th. In results to getting around, it really shut down everything, even in this area of the country that's really well adapted to major snowstorms, restoring power, dealing with, strong winds and heavy snow conditions. The poor road conditions and strong winds, blowing and drifting, really allowed for a delay in getting to homes and businesses and restoring lines and infrastructure that was damaged due to the heavy weight of the snow and ice that brought down lines, brought trees and tree limbs down on power lines as well. There were more than 35,000 homes and businesses without power. Restoration took days. And this is an area of the country where utilities are, essentially a little more, a little hardier when it comes to the infrastructure at times, and a little, used to having to do mutual assistance and respond quickly to these type of events. So imagine if something like this would occur in other areas of the country and other areas of the world as well that aren't so much used to this. But anyway, this deep snow, it really made it difficult for crews to get to the poles, the infrastructure, the substations, to get around. Um, the DOTs had trouble keeping up with keeping snow clear. And like I mentioned, mutual assistance was needed. They had an additional 70 line workers in this area to help with the restoration efforts. So 3-day liquid equivalent. So if all this snow had fallen as rain, they would have seen in this area 1 to 4 inches of rainfall that equated to, that 20 to 30 inches of snow. All right, so why was I can prove the snow is blue. We actually have pictures of this. So what was interesting is as the snow melted and compacted a bit, uh, area residents, people noticed that it had this aqua blue color. We'd never seen this before. This is really unique, right? Um, and interesting that the density of the snowpack really exacerbated the quality of the snow and it absorbed, you know, on a science standpoint, absorbed the red end of the visible light spectrum. So it transmitted the blue end, which many folks then observed this glacier blue color in the holes and the cracks in the snow as they cleared it out then. Here's a look at the total snowfall. Much of Minnesota, even southern Minnesota, had up to a foot of snow, but really impacted a large area of the northern half of Minnesota, most of Wisconsin, and the eastern Dakotas as well. So it wasn't just a northeast Minnesota, northern Wisconsin event. This was a pretty widespread, substantial snowstorm across the upper Midwest Great Lakes region. Here's a radar view from our Radar Scope Windows platform. This is the archived radar from this event. This was the first wave of precipitation that moved up from the south as an area of low pressure was starting to develop way back in Colorado, actually, and move up towards the region. And you can see all the bright banding in here in the yellows, the reds, oranges. That's indicating that you have a lot of ice and snow aloft. And this was during that mixed phase where you had rain transitioning to sleet and snow, um, and freezing rain as well. But a lot of this bright banding, you see this on radar, this usually indicates there's quite a bit of sleet or graupel that might be occurring within those, underneath those radar echoes then. And then the second round, this was at what occurred on the 14th in the evening and then into the 15th, had this, as the low approach, the area of low pressure, we have this right to left motion due to the winds driving the snow off Lake Superior, and then due to the upward force from the low pressure system, intense banding of very heavy snowfall occurred, and then we had lake effect, lake enhanced snow that was occurring due to the flow off Lake Superior as well. So a really interesting multi-phased system that led to, quite a few issues then across the region. Here's a look at some images of the aftermath during and afterwards. Notice the snow sticking to everything. This heavy wet snow causes major problems anywhere in the country, in the world that sees these type of significant snowfall events. Here's a pine tree completely weighted down by the snowfall that occurred, and branches leaning, breaking due to the heaviness and density of that snowpack. So big issues with especially these areas that hadn't gone through pre-trimming of these trees. There are a lot of limbs down, not only on lines and utility infrastructure, but on roadways as well. They had to clear not only snow, but a lot of the trees that had fallen on the roadways. So that slowed the progress of travel and getting to the trouble spots that were out there. Here's a look at heavy wet snow weighting down lines. As that occurs, leads to loss of power, significantly impacts electrical distribution, and obviously can cause long-lasting power outages. In this case, they ended up seeing many folks that were several days without power across the region. So obviously a big problem. People rely on power. There's an expectation of having power restored quickly, increasing expectations, I would say, in this day and age. So that's pretty substantial, losing power for multiple days with this type of event. Extra crews are needed, mutual assistance. You need to get people in place in problem areas before the storm occurs. Get crews and get get some equipment in place to respond immediately to issues that might occur with power lines and power loss, and especially when you have that combination of heavy wet snow and high winds. And then there's a need for additional crews as you're trying to restore power quickly. Substation and infrastructure impacts. It's well known that if an energized substation is impacted, then power transfers to other stations, and those stations might have issues. If transmission lines are impacted, then those substations can't distribute power all that effectively. So that leads to some additional problems here. All right, so let's talk about some situational awareness tools that DTN has with our new storm risk dashboard. This shows key information around what's occurring, where, how bad it is, and certain weather threats. So you notice I have 4 locations on here. They're actually color coded based on the severity of how you set up your hazard types and your forecast alerts within the storm risk dashboard. So all of my areas are being impacted right now. And if you look at a couple of these assets, these locations on the left, you can actually see color coded which hazard then is going to be expected and the actual next hazard window that is likely to occur. Within that, you can interrogate the data, mouse over. In this case, I have a warning for my threshold of 12-hour snow, expecting this to accumulate to a minimum of 6.21 inches, and 7 inches is kind of being the maximum worst case scenario. So it's really, really helpful and something new that we're adding to our suite of information to be able to assist you during these storms is we're adding upper and lower bounds in our forecast. So statistically, you can take a look at the best and worst case scenarios. We have our average forecast, but a lot of times you might want to prepare for more of the worst case scenario with these types of events, especially if it's looking like a heavy wet snow event. We do have 7 days of coverage with our hourly data, global coverage, which I'll show you a few graphical images of that, and offshore as well. So if you have offshore assets like wind farms, those can be provided this type of hazard risk information as well. And something we're adding is support for points, lines, and polygons for alerting. So if you want a certain region of your service territory or a certain city or parts of certain routes of your town that you want to be alerted for, you can actually draw area-based alerting within the storm risk dashboard and not just receive support for those point specific locations, which is quite helpful. Yeah, here's a look at some of the customized, how I would set up forecast alerts for a heavy wet snow event in here. I have snowfall amounts in 1 hour. I've set up 3 different thresholds for that. If my 12-hour snowfall amounts, wet snow. So in 1 hour, if I'm going to receive a 1/10 to a 1/4 inch of wet snow in the forecast, I'm going to be alerted on that. I'm going to get another alert and it's going to turn orange, which is higher severity. If let's say it goes to that 1/2 or to 1 inch in 1 hour, and then especially as you get over a 1/2 inch to 1 inch or more, it's in the red. Big time severe problems, impacts that's going to occur in 1 hour periods. Then you'll be notified on that as well. You can see how I set up wind speed, wind gusts as well to correlate with these kind of events. So what I would recommend a lot of times is not every situation is different, right? You kind of know in the utility space what kind of storms you can handle, especially if it's going to be a dry snow with not a lot of wind or a wet snow with, you know, 30-mile-per-hour wind gusts. That's going to lead to bigger issues. So a lot of times consulting with a meteorologist, looking at the forecast, is it what kind of snow or ice situation am I looking at? That can help you reset your thresholds based on the actual storm situation that would likely occur. And I definitely wanted to show on the left, these are some alerts that I received on my phone via text message. You can get these push notification as well based on the alerts that I set up here on the right hand side. This is a case of a high wind and snow event that occurred out in Wyoming, Nebraska, Colorado, just about a week and a half ago, actually. Um, Strong winds were expected, about 6 to 12 inches of snow. I set up different assets out here. You can see the actual spatially the wind forecast that was going to occur with our DTN forecast, and then the actual hazard timeline. I can see exactly when winds are going to hit threshold, when they're going to trail off, and things are going to be you know get much better. So this kind of thing, these hazard timelines really help you gauge when crews need to start, going out there, start restoration, get things going, and you're not having people wait around for 12 hours when snow or high winds are not expected to reach thresholds at that point. So that's not only a big time overtime cost savings to you, but manages your people's valuable time as well. Again, here's a graphical look of the total forecast snowfall that was expected through this event. I set up 3 locations here. So not only can you get a site-specific detailed hyperlocal forecast, but you have the ability to see what our DTN forecast is, the ranges that are expected to occur if you have multiple locations or if this is your service territory. You can see spatially what the distribution is likely going to be through that storm. In this case, this was 24-hour snowfall for this event. And then taking it a step further, meteogram format to interrogate the data. In this case, I put air temperature and wind speed. If you want to know kind of some of the comfortability of what the working conditions are going to be like for your crews, you'll turn this on, maybe feels like temperature, and you can see the peaks and valleys of when it's likely going to get much colder with high winds during certain periods throughout this storm. This happens to be a whole 7-day period, but you can cut that down to any, spatially any kind of time scale that you're looking for, whether that be 1 day, 3 days, or even 12 hours of data. And then within that, you can mouse over each point to see the actual value of our forecast. And as I mentioned, we're adding upper and lower bounds not only for precipitation, but for wind speeds and temperatures as well. So statistically, you're going to be able to see the best and worst case scenarios and what the actual span is in the forecast. If those bounds are really tight to the average, that's likely a higher confidence forecast than if you have a range from, let's say, 6 inches of snow to 20 inches of snow in the forecast for that event. Another example of a system last week in the Northeast U.S. This was a snow, ice, and rain event that occurred. Really a mixture of everything. I set up my forecast alerts in this case for Farmington, Maine, and we were expecting everything. Starting out as snow, changing to freezing rain, going to rain could lead to some big issues. And so each hazard timeline is pointed out here spatially in this time series on when you are expected to see those specific hazards based on your thresholds that you set up here. And then within the dashboard, you can view the radar color coded on what's progressing towards your location. And I do certainly want to mention global weather intelligence. This is a global platform. If you want to see the total snowfall or temperatures or wind speeds for the entire US or by your state, you can. If you want to see the entire northern hemisphere of our DTN forecast snowfall in this case, that can certainly be done. If you are providing mutual assistance to another utility, you may need to look in other areas of the country what the impacts are going to be. And that's certainly what you can do within the dashboard here. And then drill all the way down to street level and get as much granularity as you want in the forecast here to help you out. All right, so there are several ways that utilities can take steps to limit the impacts of heavy wet snow and ice. A lot of that is using things like outage prediction. DTN has an AI machine learning system called Storm Impact Analytics, and that understands the actual magnitude of outages by certain regions or certain cities or towns within your service areas, so that you can mobilize staff ahead of time and equipment to pre-stage and then accelerate restoration after that. And we actually provide quite a bit of meteorological consultation around that outage prediction model. So our forecasters understand how the model works, and then we can consult on our confidence levels or how things might change during that storm throughout your service area, using the best of what our human elements, our human consultation can provide, and then machine learning and AI as well. Grid resiliency investments, as population grows, accountability is growing, the expectations for fast power restoration are increasing. And so the investments in grid resiliency are becoming a lot more important. And it's important to know these storms aren't going away. And with, more cities and towns and urban expansion, the impacts from these extreme snowstorms and blizzards are going to continue, and they're going to continue to be worse just due to that fact. So I would say utilities need to be armed with the latest technology and infrastructure investments. A lot of this is thinking long term. These are very expensive undertakings, such as undergrounding the lines, stronger materials for poles and towers. So it's not to be taken lightly, sir, but in the long run can certainly reap the benefits. And then mutual assistance. You need to get ahead of this early. Competing for resources that may already be stretched thin. If you have multiple utilities being impacted, neighboring utilities, you need to get well ahead of that. They may not be able to assist you as they have their own restoration issues they're managing. So you need people from well out of state to provide that type of assistance here. So great. Well, that's what I had today. Just wanted to thank everyone for joining. I hope it was informative, and look forward to additional storm stories here over the next few weeks. If you have any questions, feel free to utilize my email, and feel free to contact me on LinkedIn as well. Thank you very much.